Hello. Welcome to this evening's TI Technology webinar hosted by Texas Instruments, where we will use TI-Nspire technology to engage students in modeling with mathematics in the algebra classroom. I see that many of you are joining us for the first time, so we'd like to offer a special welcome if this is your first T-Cubed Professional Development webinar. We'd also like to thank everyone for completing the live survey on the right side of your screen. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all students. I'm very happy to introduce our two panelists tonight, Veronica Carlson and Dan Ilaria. For 29 years, Veronica has taught mathematics at Moon Valley High School in Phoenix, Arizona, where she is currently teaching college algebra and coordinating the Title I program for her school. Recently, she was awarded T-Cube National Instructor status, and she is also an adjunct mathematics instructor at Glendale Community College. Veronica enjoys working with teachers, helping them to integrate TI technology into their classrooms to help students have a greater understanding of mathematics. Thanks for being with us, Veronica.
Well, thanks for inviting me this evening, Mike. Hello to everybody out there.
And Dan is also a T-Cube National Instructor and Professor of Mathematics Education at West Chester University of Pennsylvania. Previously, he taught middle and high school mathematics, as well as been a supervisor of mathematics for several school districts in New Jersey. Currently, Dan uses TI technology with pre-service and in-service teachers as part of his pedagogy classes at both the undergraduate and graduate levels. Thanks for joining us, Dan.
Thanks, Mike, for having us. Hello to everybody out there. Thanks for joining us.
We are expecting a large crowd, so your audio is muted. Feel free to send questions to all panelists using the Q&A window on the right side of your screen. And we'll also use the chat window to send messages. I noticed a lot of you have already been really prolific with that chat window, and that's great. One comment that I'd like to offer is if you want everyone to see your chats, which I'm sure most of you do, under the Send To choice, go ahead and send to all participants, as opposed to some of you using all attendees. So go ahead and use all participants in that chat window. This session is being recorded, and as a reminder, we'll provide a link to your event certificate of attendance at the conclusion of the webinar. Once that recording is available, if you'd like to follow along with your handheld or your software, and we really hope that you will, we do recommend doing this with the recording so you can download the activities and pause and rewind the recording as necessary. Now, we don't think you'll have any audio issues tonight, but just in case that you do, try selecting Communicate in the WebEx menu, choose Audio Broadcast, and then click Join. At this point, Dan is going to discuss our agenda.
So this evening we're going to be looking at a couple of activities that are related to algebra, and we'll be dealing with some statistics applications, show off some of the features of the calculator, and we'll be tying some connections to statistics and geometry as well, and hopefully get you a chance to see some of the power of Nspire with its multiple representations.
Thanks, Dan. And Veronica is going to discuss our expected outcomes.
Well, the thing that's neat with this evening's presentation is that we have all the activities from our TI website, and so they're all classroom ready for you to use with your students, and they all model real-world problems, and that you're going to learn how to enhance students' descriptive and analytic modeling proficiency with multiple representations. And that's what the whole thing is with modeling, is that we have multiple representations for all of these activities. And then you're also going to learn how to stay in touch with social media and more about upcoming webinars.
Thanks so much, Veronica. Dan, it's all yours.
All right, thanks very much. Okay, so I'm going to switch over to share my Nspire software with everybody out there as we get set for the first activity. since Mike mentioned that there are several people who are new to the webinar, you're looking at my software on my computer here in Pennsylvania. And so the participant and chat window did disappear. You should see a green bar at the top of your screen, and if you hover over that, you'll be able to reopen those participant and chat windows and hopefully be able to fit them on your screen so that you can still see my software completely. And hopefully everyone has had a chance to take care of that. And I'll get started talking about our first activity, which is linear modeling. And just to give you a heads up, I will be asking questions and be expecting responses as I go through this to make sure that everybody's with me and they're seeing how the modeling of the information that we're going to be working with can really help students think about the mathematics that they're working with in the classroom. So for this activity, there is a bunch of data that is related to the cost of an airplane, and we're going to look at some of those relationships. And I'll be addressing some of the questions that are in the activity sheet that goes along with this software. So I'm going to change to the second page of this activity. And here we see some of the data. I am going to look at the relationship between the number of seats on an airplane by putting that on my x-axis. And I'm going to go over to the y-axis and select another variable. You see I have several choices here about flight length, the fuel in gallons per hour, and the operating cost per hour. So I'm going to look at that relationship first so I can explore how the number of seats affect the operating cost per hour. And so now that we're looking at this data, I think it would be a good start to get some people out there to just type into the chat something that they notice about the relationship. And we'll see what kind of responses that we get. What are some interesting things that you notice that would describe the relationship between the number of seats and the operation costs per hour? Okay, so I see some responses of the data is close to linear. They have a positive relationship. There's an interesting cluster towards the center. Okay, good. And I noticed someone said that there's a funny outlier of no passengers. So that was the next thing that I wanted to bring up, is that there is this point here, and as I hover over it, you can see the value of 0 seats and an operating cost per hour of 4,804. So I'm wondering if anybody out there can think of a situation where we would have such a data point and it would make sense. And here's where we're getting at the key of the idea of modeling, that someone, a student is relating this mathematical information they have to a context that makes sense. So I see rocket ship, drone plane, cargo plane. So it would be a good. So people are coming up with lots and lots of different things. The thing to kind of drive to students is that this plane does not have any seats for passengers. So as much as, you know, it could be a pilot who decides to take a 757 to go see his mom, or maybe take his family on vacation, that's not the situation we're looking for. But it could be things like cargo plane. We could say that it's a rocket ship. It could be a mail carrier. So good, lots of good things going on there. So let's dig in and let's actually do some analysis with this data. We're going to go to the menu and select Analyze. And you know, there is always that option of regression that kind of gives us what we think is the best fit. But I really want to look at this Add Movable Line because it really allows for a good opportunity for students to come up with something that they think fits well and discuss what their possible answers would be. So I have this movable line. I can move it in two different directions. I can rotate it and try and get it to fit the data best. I can also translate it up and down. So I don't know. I think this looks pretty decent. Maybe drag it down a little bit because of this cluster. We're going to need to ignore this point up here completely because these are probably passenger planes, and this is some other type of plane, a cargo plane or a mail plane that does not have any passenger seats or ticketed seats. And so here's my equation that if I was a student in the class, I would propose as a line that models the data very well. And if I were sitting there, I would expect my teacher to ask me, what do the two numbers in my equation mean? So first we can get some responses to what the slope value of 15 and 8/10 means based on the context of this situation. Okay, so I've got some responses about cost per seat. And I like the response about the seat is adding $15.8 per hour. So it's the increase in cost, good, per hour as a new seat is added. So looking at both of those, using both of the variables that we're dealing with to look at those options. And so then what does the 363 represent in this problem? Let me make sure it's just 363 by moving this to a more central place. So the 363, which in this case would be the y-intercept, good, is our initial cost. Good, and fixed costs, things like fuel. So we want to get students to think about, so what are those fixed costs? If there are 0 seats, what things make up our initial operating costs? Okay. So good. So we've had an opportunity to have students think about the data, look at some outliers, and come up with a model for their data. And talk about what the meaning of that is. So students are using the mathematics that they know to explain what's going on. I'm going to do a quick change and change the operating cost per hour to fuel. And so we see the data has changed. And now I have a movable line again. And so I can ask the same questions. If I, maybe get a little better model here about, so, what is the y-intercept in this case? Okay, and someone has already responded about maintenance, fuel costs, right, for loading and unloading, just kind of turning that plane on, getting it working. And what does the slope mean in this context now? It is interesting. That brings up a good point about the negative value. And I was actually wondering, if I move it to a positive value, how well that seems to fit the equation. And it doesn't look like it fits it very well because it misses this large cluster. So that's why I dragged it to try and get it through this large cluster, because it would pull it down. And that brings me back to that 130 something. Yep, the cost per dollar for every gallon of gas to operate the plane. That's what we're looking at by fuel consumed is increasing, good, by that amount, by that slope value. So we're getting kids to to really look at what the meaning of slope and y-intercept is in this context. So they're applying the mathematics that they know to that situation. So I want to just stop sharing this software for a second and jump back to some information just about modeling according to the standards. And so I'm going to let Veronica kind of start off with just modeling in general based on the standards. Go ahead, Veronica.
Thanks, Dan. So the thing that's neat with modeling is that it's a content category that includes algebra, functions, geometry, statistics, and number and quantity. But it also is a mathematical practice in which we want to have problems that students use all of the 5, I'll say, strategies in terms of creating, looking at real-world problems. But we also want students to use the mathematical practice of modeling as often as possible when we're doing mathematics in our classroom. Now, Dan's going to talk to you about the modeling cycle.
Yep, and so the Common Core Standards has this modeling cycle, and the problem that we just went through was a little contrived because the data was already given, but we had students identify the variables based on what we wanted to compare. They were able to use that movable line to come up with a model, and we analyzed what the values in the model meant. Now, we could certainly go a lot further and look at specific values by having students substitute in a certain number of seats, maybe based on a class of airplanes, such as a 757 or a 777, or maybe some of those small regional jets, and interpret the results in context, which is one of the things I was asking about each one of those models is what does the slope and the y-intercept mean in the context of the problem when comparing seats and fuels or seat and operating costs. And then the final steps of this modeling cycle is that students validate their conclusions and improve the model if needed. One thing you can do in a classroom with that activity is if you have several different students coming up with different models, is talk about which one would be better and why, and use the context of the problem to help justify their arguments. And then finally, when students are at a point with a model that they are happy with, they can report out their conclusions and have some valid reasoning behind them. So we want you to keep this model in mind as we go through the other 4 activities we have planned for this webinar and see how they really play out with modeling in the idea of the Nspire activities that we're doing. Go ahead, Veronica.
So in this next activity, we're really going to focus on 3 areas. All of these bullets are talking about modeling as a mathematical practice, but we want students to apply the math that they know to problem situations, and that's definitely Common Core with having real-world situations. We want to identify quantities and map relationships using representations as tool, and that's that multiple representation. So we're going to create a situation, and we're going to look at it in different ways. And then interpret mathematical results in context and reflect on whether they make sense. And the whole thing is that we want students to always look at things and look at their result and their answers, and does that make sense? We want them to ask themselves that question and get in that habit all the time, and then for them to maybe come up with some real-world models on their own. And so, again, in this next activity, we're going to look at it in different ways. I know this is an algebra, but we're also using a little bit of geometry in this one. It's kind of a post-Pi Day activity, and so, Dan, let's get started.
Okay. I'm going to switch again back to the software. So we'll just make sure that everybody has a second or two to open those windows back up so that they can continue to use the chat window to respond. Thank you very much, everybody, with the great participation through that first activity, and we hope that continues.
All right, I'm opening up my windows too.
Okay.
All right, so this next activity is exploring diameter and circumference. And there's our title page. And so, Dan, if you would go ahead and turn to 1.2. And there you can see a nice circle with a diameter. And Dan, will you model how that is dynamic? And so he's going to pull on that point there, and you can see that the circumference and the diameter are changing. And we've seen enough of our TI-Nspire documents that sometimes that data is dynamic in that it's being captured over in the spreadsheet. And in this case, this is an older file, and so we're going to do some changing in it so then that way you can make it automatic. So when you move that circle back and forth, you can see that. And so over in the, I'm going to say the formula line, if you go to menu, menu, and then data capture, right now it's manual, and so we want to change that to automatic. And when you change that, what happens is the variable goes away, and so you have to go select the variable key, and then you want to select the diameter, and then push enter. And then same thing over for the circumference. Again, data capture, automatic, and getting your circumference, and push enter. And so now when Dan's going to go and move that point, you need to activate that window again. You can see that it is collecting that data, and it's very dynamic, and you can see it up above. And then we could do some calculations on this page if we wanted to, but this is the cool thing about this TNS file is that we're going to add a data and statistics page. And so we're going to insert a page. And I love seeing all this information. And so Dan's going to go to the x-axis there, and he's going to click on a variable, and that would be the diameter. And then tab or click over to the y-axis. That'll be the dependent variable of circumference. And wow, again, what type of function do you guys see there? If you want to just type something into your chat window. And linear, linear, linear. So again, it looks very nice, beautiful information. And so we're going to do the same type of thing that Dan did in the last activity, and we're going to add a movable line. And so we can rotate and translate our line. And this is kind of a neat activity for students to see what does that line represent. And we're getting pretty good there. And so what does the slope represent? And again, chat window.
Someone asked Veronica if you get a correlation coefficient, and that doesn't happen with a movable line. You would actually have to run a regression to get lots of data is actually calculated in the background when you run a regression, like the correlation coefficient, the coefficients of the model, as well as things like residuals, etc. But on a movable line, none of that is calculated.
And this is a nice way for students to make their first guesses when you add a movable line. And that way, the calculator is not taking care of that for you, and then they can experiment with moving it around. It's a nice introduction activity for learning how to rotate and translate lines as well. So let's go ahead, Dan, and add that, do a regression.
Okay. First thing I'll do is I'll remove that line for you so it cleans up the screen a little bit.
And you could do this as a check to see where students' equations close, and that looks pretty nice to pi there. And so we could ask questions about, you know, what does this scatter plot represent? What does the slope represent? And I see a lot of people typing in pi, but your students may not be familiar with pi right away, and so hopefully you would be talking about that. It's the circumference divided by the diameter. And again, it's a quick activity, and the thing that's really neat is when you go online, and I think Mike has all these documents, these TNS files with the teacher notes and the student notes available for you to download at the end of the webinar. There also is one where you can create this activity yourself, and it's kind of nice to actually have students create it, or you could experiment with creating it yourself, and it's pretty straightforward, and you can, again, use this as an option for something for Pi Day. Next year it's going to be pretty epic. Too bad it's on a Saturday.
And I did see a question about what's the difference between 1 and 2 in the regression menu. So I'm actually going to pull up the menu, and this way everybody can see that, and then you could answer that question for everybody.
So I believe, Dan, it's just showing, I think that's the formula that statisticians prefer as opposed to, I'll say, math teachers.
Mm-hmm. And there's lots of people in the chat that are agreeing with that.
Yeah, okay, good.
But it's definitely a good question to bring up because students will certainly ask that. Which one should I use, 1 or 2?
And then again, you can see that my y-intercept, sometimes students see that and read that as 6, but it's 6 times 10 to the negative 14, and so that really is close to 0. And so again, we can talk about exact versus estimation, and that's pretty close to 0 right there. So I do like how we have all the digits. We have several digits of pi represented there for the slope, and those are things that you can change in the mode of your calculator in the settings if that's something that you'd like to do.
Okay, sounds good. Are we ready to move on to the next one?
I'm ready.
Okay. So the next one that we're going to look at is an airport impact study. And you can see that this has the use of inverse variation. So those Algebra 2 teachers out there who came in should be happy about this one. So here's the context of the problem. That there's an airport and they're concerned about noise levels, and so your job as a student is to do an impact study and develop a model about the intensity of the noise surrounding the airport and come up with these safe or unsafe zones that would let people know whether or not, I guess, they would want to move into that area or be working in that area. And so we have a page coming up where the location that you're going to be collecting noise is shown by an X, and the airport is marked. And we're going to drag points on the axes, and we're going to be collecting data. This time we are going to do it manually, but I did go ahead and collect some of the data ahead of time so that you wouldn't watch me collect a bunch of these. But I'll actually take some suggestions as to whether I should be doing this close to our noise source, which is indicated by this point, or if I should be doing it far away. Do we think it makes a difference if one of the axes is far away while the other one is close? Should we be looking at all of these things? I'm going to move it pretty close to start while people send in their suggestions. Each time I collect a data point, I'm going to press the control and the decimal point because you see above it, it says capture. And what's going on is it is capturing those data values on the next page where there's a spreadsheet. The data points aren't on the axes. The way the file is constructed is that these open circles on the axes are controlling the location of this X, which is where the data, where we're kind of collecting our data from based on the noise level. And so you could see the distance appearing on the top and the intensity level also appearing on the top. So this is our coordinate of the x value and the coordinate of our y value. And I brought up the discussion for where should students collect this data, just because, as you notice, as I'm moving far away, the intensity level really is showing all zeros. So you would be curious what kind of model a student would come up with if they, were dragging these really far away, and then versus a student who was just maybe doing it very close to the noise source. Would they be missing things? And then does it make sense, to come on the other side of the noise source, or should we be looking at things that are much further away? So I'll just move this to one more point, and then we'll take a look at our data on the next page. And so here's all of our distances and our data that have been captured. And what we're going to want to do is actually look at this data and see if we could find any relationship. And the first thing that's suggested in the activity is that students look at two possible models. One, if the variables vary inversely, or if they vary inversely with the square of another variable. And based on the laws of physics, the intensity of sound varies inversely with the square of its distance from the source. So I'm going to go into column C, and I am going to do a calculation of distance squared times the intensity. So I'll go my variable key and select intensity, which is this intensity list. And when I press enter, I get a dimension mismatch, probably because it didn't like one of my variables. So I'll do it a different way instead. I'll select the distance column, and I will square that. And then I will look at multiplying it by my intensity column and see if calculator likes me a lot better that time. Yes, it does. So I get this 10 for every single one, and so I'm looking for some help out there as to what the meaning of this 10 is. Okay, some responses are starting to come in about constant of proportionality or variation. All right, so in our square, in our inversely with the square of another variable model, we're looking at 10 as our value of k, our constant of proportionality, and so we now have a model that is the value of 10 divided by the distance squared. And so what we can do is go to another page and change this to a scatter plot and take a look at all of that data and test our values out. So I'm going to look at distance versus intensity, and I don't see any of my data, but I could do a zoom data so that I can see all of those values. And let's actually test our model that came up from that data. So I'll go back to function, and I will type in 10 over, in this case, x squared, since that's our variable, and that looks pretty good. So this is great. We have a good model, but if we think about the question that was being asked and how it ties back to that modeling cycle that we talked about, we have our model. It looks pretty good. I think we can say that it's validated, but now we want to actually use it for something. So we're given some information about the difference between what zones are safe and what zones are not. So we can take a look at those zones back on our original graph where our noise source is. First, though, someone mentioned in the chat about using colors. So yeah, the point and the graph both showed up blue. So I'm going to do a control menu on my function and go down to color, and I can change the line color to, let's say, orange, so that I can see it going through the points a lot better. The default of the Nspire is to use blue as the first choice for each thing that it's graphing, and so since it was our first scatter plot and our first function, they both turned out to be blue in that case, but very easily changed. So let's actually take a look back at page 1.4, and actually this was, let me jump back to that page since there was a question. This, Marcia, is not on a data and statistics page. This is done on a graphs page. And so I did a scatter plot on here instead of on a data and statistics page like Veronica and I were using before. So real quick, we don't have to get into all the mathematics, but I'm just curious, if we had these three zones with specific intensity levels, then what shape would those zones look like? And I'm going to say that, just use the text box to say zone 1 is anything where the intensity is less than 0.0001. So what would the shape of the safety zone look like, or really zone 1, as long as it's less than that, based on its noise source? What do we think about that in terms of its shape? Okay, so yeah, we're looking at a boundary, and as long as the intensity level is below that, we have zone 1, and so we can be in any place as long as we're that far away, and so a circle would seem to make sense. It's a little misleading based on the graph because you're kind of going, well, I'm only in the first quadrant, so kids may think that you're going to get some other type of shape, or may not think about that the distance that we're measuring is the same distance in every direction, and the only object which is the same distance in every direction is a circle. Good point about an oval as planes approach or depart. It could make a difference based on their thrust. So, you know, this activity continues with students using their model to solve for specific distances away, and then using the circle tool, which I'll show you real quick under geometry, going to shapes and circle. Students could then select a noise source as a center and then type in, using the keypad, a specific radius. And so one of the values that you get when solving the equation for a given density is 316. So that circle, which actually looks like an oval, is the unsafe zone where the intensity of the sound is too great. And so one of the students would say that that would be an unsafe zone where you wouldn't want to be because your eardrums would definitely be damaged. And they can go on and solve other equations in order to be able to find the other zones. So you can really see the impact of the modeling cycle working in this one as students develop a model and then use it in order to make sense of a solution to this problem. And we're gonna move away from the data capture now and take a look at a different approach to modeling.
Thanks, Dan. Well, this is a favorite. It's found on the Math-Inspired website under Algebra 2, and it's quadratics, and it's modeling with a quadratic function. And so this is just a title page, and you can see the picture, how clear it comes in. And so that's one thing that you can create with teacher software, your own TNS files, and you can insert images. And so hopefully after you see this activity, it'll inspire you to look for math around you with in all kinds of things. And I'm always taking pictures with my family when I see math in the real world. So Dan, with that, would you turn the page? And what we're going to do is we're going to model data with a quadratic function, and we're going to interpret that data, and we're going to use some math models to make some predictions. And so you could start right away with what function does it look like this basketball is taking shape as this person is shooting the basket. So you can start off, and I see that match the graph is a favorite, and I love it too. And it's going to be quadratic, and so we know that it obviously is going to be a negative quadratic. And so Dan, if you would type in a negative x squared for me. And so there's our graph, and so now this is another nice time that we can go fit this graph to our data. And so Dan's pulling the function out of the way there. And so now we'll get that graph to fit as best as we can. And this is really nice if you do have Navigator software that you can do screen capture and make sure that kids are all doing it and seeing what functions they get and how close they can come. And now we can ask some questions that after we transform that parent function so that it matches the path of that basketball, what is the equation of the quadratic function? And so you have that equation there. And then in this activity, the horizontal distance traveled by the basketball is the independent variable. I'm going to ask you guys to tell me what is the dependent variable. And so if you could use your chat window. And there we have the vertical height of the basketball. A lot of people are typing that in. So now what we want to do is we can analyze this graph a couple of different ways. And so we want to find the maximum point of the basketball. How high did this basketball get? And so we can do that a couple of different ways. And so one way is to go to Menu and Analyze Graph. And we want to find the maximum there. And with the new OS update, it's very nice that you can see the lower bound, and you want to click and your upper bound, and it's just so much easier for students to see that. And so now we can see what that maximum is. Now, one thing that I didn't mention at the beginning when you saw this picture is that the tick marks there are representing 1 meter. So 2 tick marks represent 1 meter in this picture. And so one thing we want to do now is we want to figure out, well, what is that maximum height of the basketball there? And so we can quickly do a calculation where we take, well, you guys tell me, what value would that be, the x value or the y value that we would be looking at from that maximum? And y. All right. So what we can do is a quick calculation, and sometimes students love using that scratch pad. And so, Dan, we're going to take that 8.81 and go to scratch pad and enter in 8.81. and divide it by 2 because of our scale, and we end up with a height of 4.4 meters, and that's how high we got that basketball. And so just one thing you have to make sure is when you're working with students, and you need to tell them about the scale for this activity. And so another question that we could ask is, oh, you know what, let me back up for a second. The other way that we could do that is we could use a trace function. And so, Dan, if you would just go to Menu, and then Trace, and then Graph Trace, and then you can move that around. And if you just move that around a little bit, then you can see where you would find that maximum. You could go that way. But since you have Trace there, let's see how high was the ball with a horizontal distance of 2 meters from the person. So we would really want to go to an X value of 4. And so one thing that's kind of neat when you're in Graph Trace is that if you just push in the value of 4 right now, Dan, it'll jump to that. And then if you push Enter right now, it makes that point stick. And so, again, now we have that value of 7.87 that we would have to divide by 2. Dan's still in the trace mode, and so we have to escape so we can get out of that mode. Another thing that you can do that's slick is you can insert a table very quickly, and so we can do that with just going Control-T. That's kind of the shortcut for inserting a table, or you can go to the menu, of course. And there we could go to 4, and so we can see again that value would be at 7.86, and that we'd have to go to our scratch pad and divide by 2, so then that way we could get what that would be in terms of meters. And then there's a third way that we could do this if we wanted to. We could insert a page, a calculator page, and we know that this is our first function. And so if we just type in right now F1, or Dan went to go get the variable. I don't always remember the variable, so I just type in F1, and we want to evaluate this at 4, and then Enter. You can get it that way. And so there's 3 different ways that we could find where that basketball would be at a horizontal distance of 2 meters. And so let's go back to the picture, Dan, on 1.2. And let's take off that table. So Control-T, it's like a toggle switch there with the table. And the big question is, you know, does it look like if it's following that path? And really, I don't know if Dan has the quadratic model. They're really following those basketballs. The big question my students like to ask themselves is, did this gentleman really make the basket or not? And if we really look at it, it's really hard to tell, and so that's kind of a fun click poll thing. But let's say he didn't make it. We want to know how far it was when it hit the ground, how far it was from the shooter there when it hit the ground. And so how would we find that, ladies and gentlemen? What would that be called? All right, Nancy wins the prize for getting the first 0 there. And so that's kind of another thing that we can go to the Analyze menu. And Dan, if we just go through those keystrokes there, so Menu, Analyze, Graph, and 0 is right handy there. And again, it's very nice with the new OS update with the lower bound and the upper bound. We just want to really make sure that we have plenty of room where it is where we want to find our 0 or a maximum or minimum or whatever it is that we're finding. And then it's really nice that you can move those coordinates and functions all around the page there so that you have plenty of room to see things. And so again, we'd have to take that value of 15.9 and divide it by 2 because of the scale of the picture, or the scale of how this was done. And then I think it's also just important to add that you can lighten pictures up when you want to create TNS documents. And how you do that is you insert an image on a geometry page, and then what you do is with that, on that geometry page, you insert a graph. And so that's something possibly for another webinar on creating documents. So I love this activity, and it really helps me to look around and think about different ways that you can take pictures that make it very real world to students. You can even invite your students to take pictures and bring them in and share them with the class. And those are great warm-up activities, is to have students' pictures in. You can find also lots of linear models, and you can ask real-world questions such as ramps for, does it meet the disabilities requirement for wheelchairs and stuff. So kind of a neat activity. So Mike, am I handing it back over to you?
Actually, I think we should be good on time if you want to.
Okay, okay. All right, I misunderstood you. We should be good. All right, next one, Dan. And this one is multiple representations. It's also found in Math-Inspired in Algebra 1. And again, I had mentioned that these activities include student notes as well as teacher notes. And so that's always kind of nice to see what the thought process is of the author or who designed this activity. And this one has a problem situation that is not listed here. And we're going to drag our point H and we're going to observe some changes. And so I'm going to just quickly tell you what the situation is, that we're going to be looking at Tricia, and she's a 17-year-old student who receives an income from a weekly allowance, and she also works a part-time job, a paid job, at an hourly rate. And she receives her allowance, but on her job, she can work any whole number of hours from 0 to 20 hours per week. And so now we're going to explore some things with this Inspire document here. And so what we're going to do is move that H around. And Dan, if you would move it to 0 to get started. And then we want to collect that. And so we want to capture that point. And so Control decimal, that captures that point there. And so if you guys in the chat window, what does that represent? What does that that 0.0 represent, if you guys would be so kind as we're heading to the end of our hour there? Excellent. Okay. Lots of people saying that that would be what her allowance is, because if she works 0 hours, she's still going to have $10. And you can see that 3 different ways. Again, it's very neat in this activity that you see the 3 representations all on one page. We have the table there for the numeric and the grid for the graphic, and then you have that function there to show the algebraic. And so we can see that that $10 would be what Tricia's allowance would be. And so now, Dan, if you'd be so kind to move to the 8. And so if you guys in the chat window, you want to send in really quickly, what does the independent variable represent? And I do see somebody in the chat window that says that they use this activity, but it gets stuck at 0, 0. And so, Dan, would you do me a favor and go back to 0, 0 there so we can talk about things that you can look at there? Just go back to 0, 0. And so sometimes when you get stuck, what you can do is you can see how it says tab off to the side. And so if you push tab, it takes you to different options. And so if somebody is stuck, that's what you want to do, is you want to push tab, and then that takes you to the different options. So I just know that caused frustration sometimes. So, okay, go back to 8 really quick, and we'll kind of wrap that up. The last question that I asked for is, what does the H represent? And that would be her hours that she worked. And then we could answer some different questions here. So when we moved it to the 8 there, how much money would she make if she worked 8 hours? And you can see there in the function line that it evaluates it for 8 hours and that she would get $62. So this is just really nice that you can have kids explore different things. Obviously, $6.50 is not what minimum wage is these days, and so let's give her a raise. I'm going to show you how to do that real quick. You're going to go to page 1.3, and if you go up a couple of times and we just push enter, we're going to copy that defined pay rate, And there now we can edit it to 7.5. Let's give her $7.50 an hour. And then we have to push enter to make sure it sets it. And then let's go back to 1.2. And then at the bottom there at the function line, we're going to double click in by that 6.5, and then we can just edit this to change it to 7.5 as well. And so now we can verify this by just moving, or you can see that it changed there and when it evaluated her income. And so that would be a way that you could change it, and you could make it more real world. You could come up with student salaries that are in your class if they have jobs, or you could talk about how much money could they make $100, or really, let's say, could they make $400, and could the student make $400? And we can maximize this. Remember, she can only work 20 hours a week, and so no, she wouldn't be able to make $400. So I love this activity because of the multiple representation, and again, it is real world in that some high school students have part-time jobs, and then that way it makes it more real to them. So I think that's it from me, guys.